Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we are focusing on a physics topic. This is a required practical and it's an investigation into the relationship between current and potential difference for a resistor, a filament lamp and a diode. If you do find the video helpful, feel free to join us by subscribing and like the video. Share it with someone you think would also find it useful. Let's get started. So you'll need a bit of background information to this. I would recommend looking back at the videos I have previously done on the electricity topic. I'll link those for you as well. But just as a bit of background to this, you need to know that current is the flow of those electrons, those delocalized electrons in the metal wire, the flow of charge. Voltage is the push that is given to those electrons and essentially helps that current to flow. Resistance, however, is the obstruction or the prevention of that current from flowing. It actually is acting in the opposite direction. You also need to be aware of the different circuit symbols. Like I say, I've done a bunch of videos on this, so I will link them for you. But what you're essentially doing is you're looking at how current and potential difference is related to each other and the relationship they have in different components of a circuit. So let's have a look at the background. So, if we look at the different information you need to know at this stage in the course, you need to know about Ohm's law. Now, Ohm is a scientist. He came up with this idea that as you increase the current, you also increase the potential difference. And this is only when the temperature remains constant, which is quite challenging to do, especially in a circuit where wires can get quite hot. Remember that metal is a good conductor of heat or thermal energy. So, in this experiment, one of the hazards or the safety precautions to be aware of is that the wires can overheat and get hot if the potential difference is too high or the current flowing is too high. So make sure to unplug your circuit temporarily or periodically to ensure that the current and the flow of electricity doesn't increase the temperature of those wires as well. Just something to be aware of. Something also to be aware of is the maths that go with this. So we know that there's this idea of direct proportionality between current and potential difference, but you also need to know where that comes from. And it comes from this mathematical equation that voltage or V or potential difference is equal to current times resistance. V equals IR is a common equation that you'll need to know at GCSE, and you could be asked to calculate the resistance or the voltage or the current from different bits of information using that equation as well. Also, don't forget units. This is something I say to all my students in real life. When you are doing calculations, if you do get asked to do calculations, don't forget to put the units and be aware of what the different symbols are as well, because the symbols for units can often be either the same or they can often be different to the symbol for each of the actual thing you're working out. So the voltage or potential difference, same thing, has the symbol V, and it also has the symbol V for volts, which is the unit. Amps or current has a slightly different unit, so or a different symbol, I should say. So current has the symbol I, but it has the unit amps or amperes, which is A. And resistance has a symbol R, but it has the units ohms or omega, which is in the brackets there. That's kind of a Greek letter. It's a capitalized omega symbol. Just be aware of that because often I find students mix up the symbols for current when they really mean to use the unit if they get I and A mixed up. So it's just something to be aware of. It's more of a trying to make things as accurate as possible thing, but I just thought I'd mention it at this point. So, the apparatus or the equipment you'll need for this experiment is as follows. You'll need a power supply and you'll need your three components. So, you'll need your filament bulb or your lamp, which is shown in the circuit symbol there. You'll need your diode, which is shown with the circuit symbol there, and your resistor as well. I would recommend at least two resistors because when you do set up your circuit using the diode, you will need an extra resistor just to help with the amount of current that's flowing through. I'll explain later on in the video, but just make sure you have at least two resistors. You'll also need a variable resistor as well. You'll need the voltmeter and an ammeter to work out or to record the voltage and the current. And you'll need some connecting wires. And if you want to get really fancy, you can use a switch as well. This is so that you can turn the circuit on and off easily. You can also just disconnect one of the wires to break the circuit temporarily as well. Okay, so here are the three circuits that you need to create when you are doing this practical. One thing I will say is to set up one of these circuits and then just swap out the component that you're looking for. That way it will help you. I've just put them all together just for ease. So the first circuit you can see we've got our fixed resistor. The ammeter, remember, has to be connected in series to the component you're looking at. And the voltmeter needs to be connected in parallel to the component. So you can see that there in circuit one. We also have our variable resistor on the left hand side of that circuit and our power supply as well. Circuit 2, we can see we're investigating the diode, and you can see that there that the ammeter is in series to it. We've also got the voltmeter in parallel, but we have also added an additional resistor to this circuit, and that is because diodes are very sensitive and we need to ensure the resistance is quite high to ensure that the amount of current and potential difference flowing through doesn't affect the diode too much and we can get an accurate reading there. Circuit 3 as well, you can see that we have our filament lamp attached or connected. So once you've set up your circuit, we'll go through the method now. So the method follows for each of the different components. So once you've built the circuit, you want to set the power supply to 0 and essentially record your voltage and current in a suitable table. You then want to use the variable resistor to alter the potential difference and record those new readings and repeat these steps as you increase the voltage. You then want to reverse the power supply and repeat so you can get a widespread of data and you'd be able to look at the relationship between the two current and the potential difference. And then once you've got your results for all three components, you want to plot your graph, and I'm going to show you the results now. So these are the three results that you should see. Remember, these are ideal results. Often when we do experiments, there'll be human error, there'll be slightly different fluctuations in the data, which is why we do often we do lots of readings and calculate a mean average. But this is the results you should see. And for the exam, you should be able to identify these graphs, potentially plot them, and explain what they show. So the first one, we are looking at a fixed resistor, and you can see that the data points show a nice linear trend. As current increases, so does potential difference, and the data goes straight through the origin. This shows a relationship which is directly proportional, and that's important that we state that because what is happening here is we have an ohmic conductor. Essentially, the relationship is obeying Ohm's law when the temperature remains constant. So that's the first graph analyzed. The second graph is showing a filament bulb and the relationship between current and potential difference. And you can see that because it's a sigmoid curve, it doesn't actually obey Ohm's law. And that's because as the lamp actually increases the current and potential difference, it actually increases the amount of temperature that's there. The filament bulb can get quite hot, and that's because of just the way the bulb is. A filament bulb can get quite hot if it has too much current flowing through it, and therefore, because the temperature is no longer constant, you don't have that linear relationship. There's no increasing directly proportional relationship there, and that is why we see this curvature of this graph. And then the next one is a diode. Now, from previous studies and looking back at my videos, you'll have noticed that diodes are essentially used to allow current to flow only in one direction. So if the potential difference is arranged to try and push the current in the wrong direction or a different direction than which the diode wants to be, this will stop current from flowing. And that is why we see there is on the left hand side of the graph, there is that flat plateau line that is horizontal, and that's because there is no current flowing through. Thank you so much for your time in watching this video. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, feel free to give it a like and share it with someone that you think would also benefit from learning more, and subscribe. Thank you so much if you already have. It's great to have you as part of our community. I look forward to seeing you in the next one. Thanks so much. Take care. Bye.